Hello, I'm Sim Bowes. Welcome to the Net Hero podcast, the podcast about net zero. People, places, the things that are going on to change our world. But before we get on to this week's episode, two things to mention. One, our brand new website, futurenetzero.com. Go to it. It's got the tools to help you, particularly our learning and index sections that will really help you get to understand technologies that will help you get to cutting your emissions today. There's plenty more on that platform, including obviously the podcast and lots of great advice and inspiring stories. And the second thing is a date for your diary. The Big Zero Show is back, bigger and better than ever before. July the 2nd and 3rd at the Coventry Business Arena. Day 1 is all about business, 5 years on from the Net Zero Declaration, and Day 2 is about skills and how young people and older people can reskill. Giving back on Day 2, making business on Day 1. It's all part of what we're trying to produce here at Future Net Zero. Now, on to this week's Net Hero podcast. Lab-grown meat. Oh, yes, we're onto that one. People have talked about it for a while. Could it be a reality? Could we be tucking into it? And what does it all mean for net zero? But further than that, what about us growing animal tissues? This is a very interesting field of bioengineering that's looking at things like growing tissues so that we don't have to slaughter animals, but also the carbon footprint that comes with those animals so we can still use their tissues for things such as leather goods and other materials. Is it all sci-fi or is it a reality? And what will it do for actually cutting emissions? Well, I'm delighted today to say that we're going to explore that with a professor of bio-tissue engineering, Che Connon. Che, hello.
Hi, Summit.
You're also the founder of a company called BSF Enterprise, correct?
That's correct, yes, absolutely. Very proud.
Now, before we get into what you're doing, your background is a scientist. So let's go back to when you started, and I think you were a biochemist. Could you have ever imagined we'd be talking about the science of growing meat in labs?
Yeah, that's a good question. I don't think so, no. I mean, not that long ago, say 15, 20 years ago, tissue engineering for medical purposes was very much a new thing.
Yeah.
And that's where, that was my background, and that's what I got into doing.
Can you explain tissue engineering for our audience? What does it mean?
It means producing or creating tissues in a lab, in a petri dish, which are then transplanted, or traditionally in the medical field, transplanted into the human to replace a damaged organ or tissue in that patient. So the idea came about that you would, instead of trying to repair the tissue via surgery, especially if there was, you were actually missing tissue or the tissue just didn't function, you'd be able to grow or produce that in a lab and then transplant that functional piece of tissue into the person. That's where the concept came from.
And this is sort of things like heart valves or things like that, or bits and bots of our bodies. Is that right?
Yes, that's correct. Yes. So yeah, that's starting with these relatively, these are still quite complex tissues, but relatively simple compared to whole organs such as the brain or the whole eye, which no one's near recreating. But the more slightly simpler tissues, such as heart valves and things like that, are good examples. Yes,
I've heard of that because it must have been done. I assume this stuff is out there because you hear of things like people have had bits put in. And I just wanted to go into a quick thing before we talk about what we're really going to talk about. Are these basically, they take something from you so you don't get a rejection, so it's your own tissue? And people may have heard of stem cells, which we'll explain in a second. But is it kind of taken from me? So if I needed a heart valve, the way you'd take something from me so you could grow one that would, not get rejected by my body?
There are different approaches.
Right.
And some of them would have the patient's own cells, and some of them wouldn't have any cells in them at all. So there's a whole a range of different techniques and approaches, and I guess we'll go on to our approach and why we believe it subsequently became very useful in this new area. We always believe, so there's different ways of taking that tissue engineering approach where you can kind of create, say, a particular heart valve. Well, I'm going to create a plastic piece of heart valve that has the same shape
Yeah.
as a normal heart valve, and then add some cells to it,
Right.
or design it in such a way that it doesn't reject those cells in the body. That was kind of mostly the traditional approach to tissue engineering, where you try to create a composite material or a sophisticated material that replicated the function of the natural tissue.
Yeah.
Where we took a different route, at least 10 years ago, maybe longer, was where we thought, well, actually, in the body, it's the cells that are making those tissues. So let's stick with heart valve. That the heart valve is generated from cells, a particular type of cell in a particular type of environment, and so they know how to do it. So what we said, well, if they know how to do it in the body, maybe we can understand some of those instructions.
Yeah.
Why do those cells do it in the body? And if we could understand some of those instructions, we could encourage the cells to grow that tissue in the dish. And if they did that, then all of the functionality is there. So, it contains protein A, B, and C.
Yeah.
And it has them arranged in a particular way, and all of those things, which all combine to make that tissue functional in the work and function in the way it should do. So the cells know how to do this. So why not just use the cells to do it?
Why not just use them? Yeah, I understood.
And that's the approach we've taken.
Let's do a little bit of basic science before we talk about the actual tissue stuff you're growing. People have heard of a stem cell, but I think there's probably a lot of kind of confusion. Can you briefly explain what they are and why these things are so important in this whole field that you're in?
Yes, I mean, certainly I can. The importance, well, there's a difference in views of importance, though, in this field, in the cultivated meat and alternative protein field. But anyway, just as a recap for all those listeners, we can have embryonic stem cells, which are, as the name suggests, from an embryo, and they have the ability to grow into most other types of cells in that organism or in the body.
And they're like a kind of blank sheet, aren't they?
More or less. There's a couple of exceptions, but more or less, yes. And then we have the adult stem cells, which have already received a degree of programming, if you like, and they can differentiate into they can form a limited number of tissues or cell types themselves. And these tissue ones are then, as the name suggests, these stem cells are found in different tissues, and they're there to support the normal growth of and replacement of bits of cells and tissues in that organ itself. So in the heart, there'll be heart stem cells. These are tissue stem cells. And of course, it makes sense that within the body, they're controlled in such a way that they're not suddenly going to grow into a brain. They're only going to grow into some functional part of the heart. So there's two types of stem cells: the tissue stem cells and the embryonic stem cells, or adult stem cells.
Yeah. There's a lot of stuff that people may have read in the press about how you could grow these into anything. So there's part of that. Let's talk about what you're specifically doing. So correct me if you're wrong. You came out of Newcastle University. This is a company that's been spun out of that with some great research that's been going on up there. And you're looking at lab-grown meat, but you're also looking at creating lab-grown sort of skin for things like leather in the fashion industry. And you're also growing sort of small organs such as corneas, things like that.
Mm-hmm.
I want to cover all of that. Why go into this field of lab-grown meat? Because a lot of people have said, this has been in the headlines for the last kind of 3-4 years. First, we had the whole kind of, vegan burgers. Everyone knows the brands that are out there, and I've had them. They taste pretty good, and they taste like a burger. And then people said, no, actually, why don't we just have meat, but without the cruelty? And why don't we have meat without the carbon? So, why, number one, your interest in this field, and number two, what exactly do you see the role of lab-grown meat being in the world of emissions reduction?
So to start with, as I said, our interest was in getting cells to grow into tissue.
Right.
So all of the parts of that final tissue were cell derived. And the first tissue we demonstrated this principle with was the cornea, the transparent tissue at the front of the eye, so that you could create corneas for transplantation and solve donor issues around this particular tissue. So we have made amazing progress in this process, and that then formed a platform technology, which was then spun out from Newcastle University into a company called 3D Biotissues. So we have this platform technology that allows us to take cells and direct those cells through a range of what we call biophysical cues. So it's just the environment in which those cells are grown,
Right.
and gently coax them and give them some initial information, and then they which they then follow, and then they take it from there and do all the hard work and arrange themselves in a very highly ordered way and produce the right proteins in the right places at the right time. And they do all that by themselves if you've given them the nudge in the right direction. So we had that process, and we were thinking, well, the cornea is good, and let's look at the cornea. But also we thought, well, what else could really benefit from this technology? I'd been interested in cultivated meats, as it's called, for a number of years. I'd been following Mark Post in the Netherlands, who did the first hamburger about 10 years ago. So, which is a tissue engineering interest. So I had that in me. So when we were thinking about other applications, I thought, well, actually, this cultured meat area could really benefit from our technology.
Why was your interest in sort of this lab-grown meat? You talked about the process where you'd started to work on, obviously, corneas and looking for replacements for surgery. What made you pivot to look at meat? You call it cultivated meat, I think, this kind of lab-grown stuff.
Because we knew that the process that we developed and the platform we developed for creating tissue-engineered constructs had all of the structural characteristics. The final product had all the structural characteristics of the natural material.
Right.
And we believed that would create meat, as we call it, meat as you know it.
So it'd feel like a piece of meat. It would have the texture, the flavor, all of those things.
It would have the texture, flavor. It cuts the same way, reacts to heat, so it cooks in the same way. Because all of those characteristics of meat, how we expect it to react and taste, etc., are all due to the microstructure within the meat itself. So what it's made of exactly, how those are arranged, aligned. Those are all the things that then cause the meat to react to shrink in a certain way when it's cooked, or crisp in a certain way, and also bite and chew in those ways too. Because we can create all of that microstructure, we were confident that it would pass that Pepsi challenge taste, and people would chew the meat and go, yeah, that's meat. And that's exactly what happened when we had an internal tasting.
Right, here we go. This is the bit that everyone's going to want to know. So a couple of quick questions. Here's your rapid fire round. What does it look like? So does it look like a piece of, I don't know, pork or lamb or whatever it is? Is it red in color? Does it grow that? Do you grow it on a strip of something, and then you have to tear it off? And then what the hell does it taste like?
Well, we were basing, this is a pork product that we've been demonstrating, so which is obviously a paler meat than a beef cut. So it had the color was there, and it was more of a fillet approach. So we didn't focus on having layers of fat, visible layers of fat, or
very good, very healthy. I like this.
Yeah,
okay.
That's right. So it's a fillet cut. So it looked very much like a fillet. It had these, it has the large bundles of highly arranged fibers that, if you've ever kind of tried to, dissect your pork or any of them, you can see these fibers in there.
Yeah, of course you can. Yeah.
It has all of that in there.
And what did it grow on a jar, on a dish, like?
Yeah, it's grown in the laboratory. Yes, and
wow.
Process, or is it difficult to kind of go into all the details?
No, sure. But and just how long does it take to grow a piece? Let's say you're getting something that's kind of, I don't know, 100 grams of meat, right? Something that people are supposed to be about 30 grams, whatever it is. Anyway, people know what kind of steak is, or a pork fillet would look like, or a pork chop, whatever. How long would it take to grow that? And then the one I wanted to know is how it tasted.
Well, of course, these things are all up for development and things, but in this case, in that example, it took 2 months to generate
2 months, right?
Which is obviously a lot less than it takes for
of course,
a pig to grow.
Yeah.
You're still growing things and using cells to produce in exactly the same way the cells would be growing in the body. We can enhance and accelerate that. We've developed some other technologies that accelerate that process. We've got some of those we sell actually, but we do have some really nice technologies that facilitate this process.
What did it taste like?
So it tasted like pork.
How did you cook it? That's what I want to know.
We fried it in, so it wasn't we were keen not to dress it up or
Yeah.
anything
That's
else.
what I
So
was
we
going to say.
just,
Too many spices,
yeah,
and then you suddenly know
no,
what am I tasting.
it was a little bit of oil
Yeah,
fried in a pan, and I
yeah.
think there was some salt and pepper, and that was it.
Okay, so of the people who tasted it,
Yeah,
how did they feel?
I guess surprised how much it was. Their brains told them it was pork.
Right. This is sounding like the Matrix to me. Do you know that bit where he says, "I know that this steak doesn't exist. My mouth is telling me it's doing."
Yeah, it's a powerful thing. So I hadn't really appreciated how powerful the signals. When you're biting down
Yeah,
and
yeah.
the mouthfeel, your brain is tuned to be very sensitive to those things.
Correct.
And of
Yeah,
course, if you
yeah.
start thinking about it, you can taste the.
Yeah, of course you can taste a chicken, you can taste vegetable, you know exactly what it is. And when you
And a lot of it to do with
yeah.
it's not just the flavors,
No, it's that mind connection, yeah.
it's the texture and how much force it took to because this is why it's so difficult to generate these types of meat through other means, because the complexity in that structure the cells are quite able to do is incredibly difficult to recreate through other means, because the structure is such that you can imagine now if you bite down on a piece of the stick of pork, initially as your teeth close on it, it's relatively soft,
Yeah.
but then it stiffens
Yeah.
up as the more force you apply, and then it snaps at a point where it's a bite occurs, and your brain recognizes all of those forces and all of and how much effort and all the rest of it, and associates that with different cuts of meat. But to try and to create a material not using cells with that level of complexity is almost impossible. And you can kind of get a sense of that when we see this some of the struggles in creating plant-based
Yes, of course. Burgers.
alternatives
Yeah.
that have the bite. The difficulty in doing that is huge.
It's a different kind of protein, isn't it? It's a different
Yeah.
structure. Yeah. So it tasted all right.
Yeah, tasted like pork. Yep.
How many did you have?
Well, I certainly went back for
For
another
seconds.
pork. Yeah.
You didn't have to wait 2 months for it to grow again, did you?
No, I made sure it was enough.
So this stuff, and I find it fascinating, really fascinating, because it's a really interesting thing. Where did you get the actual cells that you grew this from? Because this is also part of what people say. Will there be genetic engineering? Will scientists start having to siphon out cells from living pigs, and there'll be one pig that you use to grow all of this stuff, and one chicken and one lamb, whatever it is. And then the other thing is, how realistic is this to be kind of mass produced?
Well, I mean, the question, which is a fair, people want to say, well, where does the cells come from, and are we messing with things? Importantly for us, and our approach is that we're agnostic to the cell type and where it's come from. So it works with a whole range of different cells, and depending on if they've just come straight from the animal, or if they've been so-called immortalized or other things, it will work with a whole range of cells.
But it comes from a pig, yeah? The original, you're not making a pig cell. That's what I'm trying to get at.
Particular example, which is an example we were showcasing the, if you like, we'll call it downstream of the cell. What you can do with cells and how you can turn them into a functional steak. That's what we were showcasing. But the cells in this case came from a pig, an adult pig. Yeah.
So, mass production, and right now it's all, it's still a bit sci-fi. People have had little examples, and there's been videos on the internet you can see of people trying it. Where do you think your technology is to scale?
There's certainly challenges around scaling up.
Right.
We are very much of the opinion that we need to create a meat which is recognizable as a meat.
Yes.
And that's a big part of 3D Biotissue's ethos in terms of applying this powerful platform technology. We think that in order for it to be successful longer term, this cultivated meat, it needs to be reminiscent, more than reminiscent of what meat is, and fulfill that urge or need that people have to chew and bite and taste meat.
Yeah.
So we want to get that bit right, such that once it is scaled up, we're not going to be left with a lot of disappointed customers.
I was going to say, yeah, I get it. In terms of kind of that whole, you're growing it and you'll test it all out. What do you think it does? Because the argument is that if you can grow it, you get rid of the carbon footprint of the animal and the livestock side. And everyone probably knows there's a huge carbon footprint with the amount of water an animal like a sheep or a cow needs, the food, the greenhouse gases emissions that go around that. There's got to be some emissions around this, but how do you say the effectiveness of this cultivated meat is in terms of cutting our carbon footprint?
Well, I'm not going to be able to give you any numbers on that.
No, that's fine.
But it's just a principle that if you can control the entire process and and have it in a confined way, in a highly controlled way, then you have a much better chance of reducing, the bits you don't want, right? Whether that's CO2 or whether that's particular waste or methane or water use, how the water's used,
or the excrement, all of that stuff.
So you've got a much bigger control over that, allowing you to make efficiencies and protect the environment in a more controlled way. So it's just that it is an industrialized process. You can't kind of shy away from that.
And of course, no, I'm not saying that suddenly you're growing this with no energy, of course.
Yeah, so it's an industrialized process, and it's a way of managing each of the steps towards meat and having control in each of those steps. Whereas at the moment, you give it to you just say, well, there's the piece of land, cow. You can't control where exactly you're going to eat, or all the other aspects of that. You just control it more. So you just have more control over the whole process.
I mean, some of the things that would strike me if I wanted to eat it, people would say, people talk about antibiotics, right, in meat. They talk about all this sort of stuff. So I'm assuming, A, there isn't waste. You're not growing a whole animal, so you're just growing the bits you want. And B, I'm assuming you can grow this without the risk of kind of disease, because if you control it all. So are those two fair statements or
yeah, absolutely. Yeah, absolutely. There's some good examples of if you can control the, fundamental process, all those fundamental processes, then you can make sure that you don't need antibiotics, because you shouldn't have anything to kill off in there in the first place.
Yeah.
As you said, you're focusing down on bits of meat that people want, rather than and reducing the amount of waste associated with the animal.
What's been your conversations? I'm sure you've probably had them with kind of animal groups, and that whole argument. And it's a big one, because this is the end of it. If we're going to change culture, then people have got to accept to do this. And there's an animal cruelty part of this, which a lot of people have an objection to meat because of that. So do you look at that, or is that kind of more of a philosophical argument that you think is for other people to make? Because you're going, right, I'm taking the cell from a pig and I'm going to grow you some pork chops or whatever.
I think, from a personal perspective, I think if I have a technology which can significantly reduce animal cruelty and the use of animals, then it's really, I feel it's important that I do my best to make that a reality.
Have you had any conversations with any sort of animal groups about this sort of stuff?
No, not directly. No, I mean, there's lots of, there's conversations out there. Because you end up, it could be about vegans or not.
Correct. Yeah, exactly. Yeah.
But veganism, it's an emotional. There's a strong emotional attachment to veganism. So, and we may have time to touch upon the vegan leather, for example, which well intended.
Is made of plastic. No, I've covered this on the podcast. Yeah.
So it's not. I'm happy for vegans to kind of jump on board and make the most of it, but it's not. We're really kind of addressing the core of people here, who most of them enjoy meat. So
yes,
how do we convince them that this is important?
The thing is that the facts are bonkers how much we eat, right? I think chicken is the most eaten animal on the planet, and I think we've got to start here. I think from you guys about China, for example, eating something like 100 million tons of pork, right? So I don't think meat consumption is going to disappear, and it's a very big thing for people in the whole emission side of things. Do you think that what you're doing, can you see the hardest challenge being me, the consumer? Because I think you could probably solve all these things you're talking about, scaling and all of that. I reckon there's technology to do that. But it's about whether I'll go and buy it from my supermarket, isn't it?
Exactly. That's exactly right. And that's why we feel that having a product which is unrecognizably, there's no difference between that and what they're used to eating is really important here, because the uptake will follow. I'd like to get to the point where people aren't even thinking about when they're making that purchasing decision. Purchasing was like, well, is it cultivated, or and they're not being able to tell the difference. Getting back to that Pepsi Taste Challenge.
We're a long way from that, though, aren't we? Really?
Well, I don't think so. With the technology we have, as I said, going back to our tasting, internal tasting session, it tasted like pork. It had the same mouthfeel and all the rest of it. So we do have it. We have that technology.
I'm going to start to feel like this is the $6 million man intro.
But there are challenges there.
No, sure.
What the approach we've taken means that the scaling up is different and requires different approaches, but we want to make sure that that final product is going to be a success versus cutting corners or making decisions based on what we can do today in terms of scaling up and ending up with a pink goo and then having to spend an awful lot of money and time trying to convince people that this is a thing you want to eat.
Yeah, too right. You've gone some way into trying to scale this. I think you partnered with some farm agriculture companies and things like that. So how far do you think we are away from seeing this cultivated meat in our supermarkets?
We know that the people are already applying a form of cultivated meat, which is called a hybrid product. So it has some meat cells and a plant scaffold. So those are, it has approval in the US and Singapore.
Right.
We saw a public tasting session, I think, in Netherlands a couple of days ago.
Right.
It's definitely happening at the moment. Now, this will have to move, and we believe it will have to move. The product will have to move towards something which is much more recognizable as meat, and move away from the plant-based meat.
Yes.
In order to really,
exactly. I agree with you. I mean, I've tried them. I thought they're all right, but they're very salty. There's lots of differences. Fundamental thing, is that it doesn't taste the same. So obviously, lots of hurdles, lots of legislation. You'll need governments to approve it and all of that thing. But do you believe by the end of this decade we might be eating this in the UK?
Yes, absolutely. Yeah.
Okay. Cook it up right now. We're going to have to leave it fairly soon, but I just want to touch on one other thing, which is your leather. So you're growing skin right now that's actually going into the fashion industry, correct?
It's certainly within the fashion industry's development teams, right, for sure.
And the idea is that this skin, like a cow skin or whatever it is like real leather, but it is grown without the animals having to die or anything like that. And the difference is there's no plastic, because I've covered the vegan leather thing, which is basically from hydrocarbons. This is basically a bit of skin that you can tan and do anything you want.
Yeah, that's right. Yeah, again, the same process that we developed to get those cells to organize themselves into and grow and produce all these structural elements that form a big part of a tissue. Yeah. So just to underline the point that a tissue is not just made of cells; it's made of lots of what they call extracellular material. So stuff that comes out of those cells. Yeah. The structural elements of a tissue are not cellular; there are these other bits, and that's really what gives that tissue its function, whether it's to contract or whether it's to be hard wearing or whatever, cornea transparency, etc., etc. These are not cell based; these are all extracellular based. So the fact that we can get the cells to do all of that and create these extracellular components of the tissue means that the final tissue is functional or reactive in the same way that the animal tissue would be. And so, for the leather industry, it means that the skin that we are creating can be tanned and treated, embossed and stitched and finished in exactly the same way as traditional hide would be. And that's particularly attractive to the leather industry or the fashion industry because they've got a lot of expertise and a lot of machinery and things
and a lot of public pressure as well. Yeah.
Yeah. Well, that's right. But it means it makes it more commercially sensible, because they know that the end product's not going to be any different from the end product they've been selling for hundreds of years.
Yeah.
But at the same time, addressing growing public demand for, whether it's in the fashion industry now, whether that's better animal welfare, in terms of where their products come from, and or the environmental impact of
lower emissions,
of their resources, etc.
Well, I think it's been fascinating. It really has, and so I wish you all the best. I do. I think
Thank you very much.
What you've created here is really, it's one of those things, isn't it? Until someone makes it, you don't know if people are going to buy it. So I look forward to a taste challenge with you. So, maybe we can catch up and, you can cook me a bit of your lab-grown meat in a couple of months' time.
I'll put your name on the list.
Do. That'd be great.
Okay.
Con, thanks very much for having a chat with us. Really been brilliant, Jay. So, Jay Conlon from BSF Enterprise. If you think that lab-grown meat is the way to go, let us know. Get in touch on social media. What have you thought of the discussion we've had today? Was it something you'd try? Would you wear leather that's grown from a lab? All things that I think will be all part of the discussion as we look at how we can cut our emissions. Remember, if you're interested in anything to do with that, log on to futurenetzero.com. I'll be back with another episode of the Net Hero podcast next week.
You've just heard the Net Hero podcast from futurenetzero.com. Join us as we help you find ways to cut your carbon footprint as we head towards net zero. Subscribe and follow us on social media. futurenetzero.com. Better business, better planet.